This is John Black, Super Chemist. We're here to make some hydrochloric acid, concentrated, hopefully. I did a video already how to get. You can buy uh, concentrated HCl, or I think like 32.5% at the Lowe's or whatever, the hardware store. But we're going to make it this time. It's not just how to get, it's how to make. We need two things. Here's the equation. Sulfuric acid and most or probably any chloride. I don't want to get no crazy salts though. Sodium chloride's the easiest one to get. I'm not purifying nothing. I'm just using drain cleaner and table salt. Okay. You can see you add them together just like any other acid. You get the salt that has the same anion as your acid, and you drip a stronger acid on it. We want hydrogen chloride or hydrochloric acid, so we get a chloride salt. Our strong acid is sulfuric acid. It'll make bisulfate and your gas HCl. Okay, now this isn't making hydrochloric acid, this is making HCl. Now this happens at room temperature. If you want this, because this is an acid too, right? It's got a proton there. If you want it to do some of the work, you would have to have it above 200 degrees Celsius. If you don't heat anything, then it's this one. So obviously you can, if you have some more salt in there, you can heat it up and you'll get even more HCl. So if you want to combine these and you're just going to heat everything from the get-go, as you can see, this would be the formula. You'd need two chlorides, one for the, this first part, and then one for here, right? Alright, so my apparatus I'm going to show you here soon, it looks very complex, but it's very simple. The way you do this is you drip this acid onto the salt. So here's a set funnel, round bottom flask. You drip this sulfuric acid into the table salt that's in here. It would create gas, and then you use a hose. See this cup of water? And there's an ice bath, so it's nice and cold. You know what I mean? The colder the water is, the more soluble the HCl is, right? And you can see the hose. You put the hose all the way down at the bottom, so it has time to go through all that liquid before it escapes. And it's that simple. Now for this setup, and I have done this many times like that, it's terrible, okay? If you don't have a fume hood, oh my. You're in and out of the room every couple seconds because you can't stand it. But that is the simplest setup. If you're doing it outside or something where you can get downwind, this is great. If you're not experienced, you know what I mean? You got to watch for suckback, all right? If you don't keep up your production, right, and you stop production, you're going to have a suckback. You're going to stop creating gas. The gas will all dissolve in here, and then you'll have a vacuum, because as the gas comes out, you have empty space now, right? It's going to suck up all your crap into this flask and ruin your reaction, all right? And that's why you should put a suckback trap on. Now, if you don't have two round bottom flasks, you can always do this. This T part would be like for distillation, but instead of having to go to a condenser, you'd have to go to a hose, just like over here, right? You'd lead that hose into that cup of water that's in the ice bath. Here's your set funnel. Here's your valve. So if you don't have any two neck round bottom flasks, you just have one. You can always be creative, which you'll see with my setup, which is this. Okay. Now this looks nice and simple. That's why I'm showing you on paper, because when you see mine, it does not look like this. All right, because I don't have 1, 2, 3, 4, 5 two-neck round bottom flasks. I don't have all the, But anyways, this is the same setup I just showed you over here, right? You got your sulfuric acid. You're dripping it into your salt. Creates the gas, which comes into here. This is empty. And the reason why is in case. So basically, this is just a hose going to here, because this is just an open apparatus. Think of this as a thick part of the hose. Comes into here. This is where you have your water, your 100 milliliters. That's what I'm working with. It'll bubble the HCl into the water, but not all of it's going to stay in there, right? And you'd have your ice bath on here, right? And then your escaped gases can come out this hose, go into here, And again, this is empty. This is just like a part of the hose. Just think of it as a fat part of the hose. Comes through here, and I'm going to have sodium hydroxide in here, and it's going to get bubbled through the sodium hydroxide all the way to the bottom, so it has time to absorb it before, dissolve it before it gets out of there. So some stuff's going to even get past there. So I got a hose coming, and I got a graduated cylinder that's 100 or 1,000 milliliters, so it's tall. I don't care that it's wide. I want it to be tall so that it has a. I'll put the hose all the way at the bottom, so it has a real long time before it has to get out to escape. Has more of a chance to dissolve it. You know what I mean? Being that it's so long. Being fat doesn't do anything. Then I'll cover this up, the hose part, with like a, you know, some paper towel or something, just in case. It'll have to absorb through the paper towel too. Now when you see my setup, it doesn't look anything nice like this. It's all, well, now that I'm looking at it, it somewhat looks like this, but not really. That's the actual setup. You can't even see the beginning. I don't know if you can see the funnel up there. Looks all complicated, especially with the Mars in the back. Alright, here's the equation. Here's your molar masses. I have 95%, I'm guessing I have 95% sulfuric acid, so I divide by 0.95, and I get 56 milliliters for that, and 58.4 grams for that. Now I want you to look at something now. Alright, now if I have 100 milliliters of 38% hydrochloric acid, which is what I'm shooting for, right, it has a density of 1.189, so I take that 100 milliliters, because I don't want milliliters, I want grams. So I multiply them to get the weight of this sample here, right, that I want to make. That comes out to 100, let's say 119 grams. This weighs 38% by weight is HCl, so 62% by weight must be water. So if I multiply these by 38%, 62%, this is how much HCl would be in there, and this is how much water is going to be in there. That's why I decided on putting 73.4 milliliters of water into the flask that's collecting the HCl to make the HCl acid. So I decided the water was 73 point whatever. Now if you look over here, see, the molar mass of HCl, just the gas, not the acid, is 36.46. We need this much, 45.182. So I divided, right? Because I want to know how many moles is that. If 1 mole is this, how many moles is that? It's 1.24 moles. That's how many moles it is. Alright? So, look over here. That's 1 1/4 moles almost. Now look at this. Alright? We decided on 56 moles for the sulfuric acid. So we're going to take it times 1.74. Why? Because we need at least 1.24, right? I'm going to add another half a mole in there for loss. Okay? You know, you got to fill up the apparatus, and stuff ain't going to be absorbed. All the loss, I'm going to hope that it's a half a mole or less. Alright? Because I'm putting on a half a mole. Half a mole, right? 1.24 plus 0.5 would be 1.74. So I multiply that by 1.74. This is the sodium chloride, remember? Sodium chloride was 58.44, so I took that times 1.74. That comes out to 101.7 grams of table salt. Comes out to 97.4 milliliters of sulfuric acid. 73 milliliters of water, or 0.78 that we're putting into the collection flask to collect that HCl. And that's how I figured out my amounts. Now look, we added 73.7 milliliters to this 100 milliliter flask, right? We know that when we get done with it, if we have this much whatever, and once we have the If we have this much water, then we have to have this much acid. And if we do, it'll be 100 milliliters at 38%. So what I did was I put 100 milliliters in here, and I don't know if you can see it, but I put a line around there. See how there's a with a magic marker. It's not perfect, but it's approximation. That way I know when I have enough HCl in there, it should be somewhere around that line, right? If I do get it to that line, then that means this is 38%. If I get it below the line, that means it's, you know, almost 38%. We'll have to do a density check test. Alright, I don't want the camera on while I'm starting this, so I'm going to show the apparatus first. You can see right here where my finger is, right? That's where the 100, that's where the 97.44 milliliters of sulfuric acid is. Then it drips down into this bottle here, and there's salt in here, right? And you can see once it goes out of the salt, it comes up here. It's just a tubing, a glass tubing. And then the tubing goes out here, but look, this is just an open, you can think of this as part of the tube, you know what I mean? It comes up here, there's a tube in here. It goes all the way down to the bottom of this round bottom flask right here. Now, it bubbles through the water, right? And then it comes up here through here, okay? Comes up here, around here, to here. Now, I did put a little bit of water in here, even though this should be empty, because this is a bigger bottle than this, because this leads into here now. It's going to bubble through here. This has sodium hydroxide in it, right? And it'll bubble through here. Now you can see it comes out here, around here to this 1,000 milliliter graduated cylinder. I only put 250 milliliters in it because that's how big this is. So what's going to happen here, right? So if a suckback happens, this will go and get sucked up through the tube to here, not to the pot, right? This cannot get sucked up because there's no tube going down to the thingy, right? This will get sucked up into here and fill it all the way up because there's 250 milliliters here, there's about 200 there, it should be up here, you know what I mean? But it can't get sucked back up into there. And then this will be sucked into here from this graduated cylinder, and it only has 250 milliliters in it. I figure I can add more later on if I want, if it's smelling up the place or whatever. This is the gist of it. So I'm going to start the reaction now. To think about it, even though there's no tube leading into this water, it will absorb some hydrogen chloride and become hydrochloric acid. Dilute, but still. This will create sodium chloride in water. Oh well, maybe I shouldn't have put so much. It's going to make water too. Anyways, then it will go back here and make some more hydrochloric acid because there's just water in there. Now you can see I got my ice bath here for the HCl, and up here where that graduated cylinder is, see how I jammed a towel in there. I mean, it's like a filter, not a plug. You want to put it in so, you know, it's not too tight. You know, and plus it can escape here a little bit too, so it won't build up pressure. Add 100 milliliters of sulfuric acid. I didn't do anything to it to clean it up. And I put 114 grams of table salt plus another 37 grams. Because I figure if I don't have enough, it's easier to add this sulfuric acid. And, you know, if I have a little bit in here, I can heat it up or whatever or anything. So here I'm going to start it up. Just want it to drip.